not. And that's going to be another thing you're looking into. And then finally, sorry guys, I moved some people up, so you're going to have to be at the back here. But you might need to stay as part of the activity. The fourth one is going to be on diet. If you're able to, yeah, go ahead. If you're able to have a healthy diet, then you should be good to go there. Take another 35 seconds while I'm taking attendance. Again, all you need to do is circle it. You don't need to fill it in.
So, these are class times.
Today in science has changed a little bit. I feel like I end up focusing on just one subject matter in current events more than others. So I'm going to start rotating them out. And so I'm going to specify the field of science that we're studying on a given current event. So today in science, this time, is today in astronomy. We've been talking a lot about exoplanets. Can somebody remind me what an exoplanet is? Charles?
Exoplanet is a planet outside of the solar system.
Yes, exactly. A planet outside of the solar system. Outside of the what?
Solar system.
If it's outside of the solar system, it's hard to see. And a lot of these we haven't discovered until very recently. These ones in particular are very small. But what's unique about them is how old they are. These are planets that are 11 billion years old. To give you some perspective, our Earth is about 4.3 billion years old, give or take. And our solar system isn't much older than that. Now, because these planets are so old, it gives us a little bit of information about what's possible on other planets. First of all, if you have planets that are this old, that means they have almost 3 times the likelihood of being able to develop life because they just have more time to get it figured out. The second thing is that planets like this must have been around when some of the earliest stars in the universe were. So the earliest stars died after about 400 million years, more or less. Can anyone give me an estimate about how old our sun is? Does anyone remember? Something we talked about last year, but we haven't covered it this year because we've been focusing on life science. Mel, do you remember? It's more than that. It's more than that. Dane, second guess? More? That would be less than what he said, so it could be more. I'll take one more guess. Hunter? Answer, and then you can go. Well, I'll tell you this. If you were to actually measure the age of the sun going all the way back, you'd probably have to get into the trillions. So I'll have you guys look that up and get back to me on another day to get the exact answer. If you look in last year's learning ladders, you should be able to find the answer. So I don't want to give you any more. But one of the things that you'll find is that these really, really old stars, they died so young that all of the stardust got scattered and got made into new things, and that's what these planets are made of. They're very small, about the size of Mercury, and we think that if we look for other planets like this using our new technology, we may be able to find better chances of evidence for life. I'll take 4 questions on this. 1, 2, 3, and that's it. 1.
So, another question and another answer for this.
There's just 2 questions.
All right. So, if it came out of the sun, right? How would you have life if you just burn it then?
True. Okay, so let's talk about what happens when a star dies, right? Last year we talked about 3 different ways, but if you weren't with me last year, then you may not have learned this yet. There's a couple different things that can happen if a star dies. Does anyone remember any of the possible ends? What happens when a star dies? Sean Smith? It could collapse, and there's a couple things it can collapse into. One of the things is called a dwarf. It could turn into a dwarf, and eventually, there's actually a stage after that. Let's try another one. Go. A black hole. Does anyone remember what a black hole is? Can someone just describe it briefly? Sean?
It's a mass that sucks in other things. And
Using which force?
It's gravitational pull.
It's gravitational pull. Very nice.
And it basically consumes everything that's around it.
Yes. That is the most massive stars. They collapse into a black hole. However, there's other kinds of stars. So a star is made up of a ton of different atoms that are fusing together. There's 3 particles inside an atom. Can somebody give me one of the particles? Go. That's a type of atom. There are particles inside of it. One is positive, one is negative, and one has no charge. That should be a hint for you. I'm going to have someone else come with one, and then I'll come back to you for another. Go. Neutron. A neutron is neutrally charged. What's another one? Go.
Electron?
Electron. What kind of charge does an electron have? Well, there's electron.
Like positive.
Yeah.
Two positive.
What kind of charge? Well, the only option that would be negative is what? What's the positively charged particle called? What's the positively charged particle called? Yes? Proton, correct. So when these guys are undergoing their energy production, it's called fusion, these protons and electrons end up fusing together and making bigger and bigger and bigger in atoms. But eventually, the protons and electrons run out, and the star's out of fuel. If all the protons and electrons are fused, what kind of subparticle is left? All the protons and electrons are used up. What subparticle is left? Melvin? Neutrons. We call that a neutron star. It's like a car out of gas. It can't produce energy anymore. And they spin around in space really, really fast. They have some gravity, but they are very dull. They're not producing light anymore. That's another way that stars can die. Mr. Shaw has rambled so much, he forgot the original question. So I'm going to move on to 2. 2?
Oh.
Yes.
How can we actually calculate how old a star is?
Okay, that's a good question. It has to do with a lot of different factors. One of the factors we can look at is light. One of the factors we can look at is mass. And one of the factors we can look at is distance. So does anyone remember what a light year is? How does a light year define? A light year. A light year. Oh, you answered the last one, so I'm going to go to somebody else first.
Okay, I don't remember. Like, is a light year like how fast a light? You know, like something like in the speed of light.
It's related to the speed of light. Can somebody build on that? Can somebody build on that? Go.
Isn't that like how fast the light travels for light to get to a certain place, like the shine or something?
Why is it called a light year? Okay, help.
And because the year is the same amount of time. I mean, same amount of speed as light.
Light year is how far light gets in one what?
Second.
It's a light year. How far light gets in one?
Year.
There's also a light second, there's a light minute, there's a light hour, there's all these kinds of measurements that we use. But if you're really, really far away, that means light's taking a long time to get to you. If you're 1 light year away, and what you're seeing a light year away is a year in the past. And so when you measure the distance of something, you can actually start to measure time as well. That gets to next level physics, which we don't have time to get into today, because now we need to talk about psychology. Take a look at your do now. If your best scored, really, Mr. Shaw? If your highest scored category was on exercise and sleep, give me a pound on clap. And if you have ties, you can pound clap twice. If your highest scored category was on friends and fun, pound on clap. If your highest scored category was on stress, pound on clap. If your highest scored category was on the brain feeding diet, give me a pound on clap. For myself, I would say exercise and sleep. I try to get 7 hours of sleep a night because it wasn't really a grumpy Gus to you guys, and I'm really just a jerk. But unfortunately, I don't really exercise much of that shit. Like sometimes on weekends, I don't know. I don't lift like a lot of the teachers here do, you can probably tell. So I'm leaving that as a 3, halfway there. Friends and fun, I tend to do stuff on weekends. I don't know. I'm a more of a loner anyway, so I have time just kind of reading articles about stuff. I don't know if that's me. Keeping stress in check. Usually if I'm angry at you guys, I'm faking it. So I think for the most part, I tend to be okay. And then as far as a brain boosting diet goes, I eat healthily, but not as healthy as my girlfriend does. She eats sweet potatoes raw. It's really weird. She will actually take a sweet potato and on it, which I can't do. She has like rabbit teeth. I don't know. I love her, but she has rabbit teeth. So she's healthier than I am, so I can't, in good conscience, say 5. I'm going to say 4. These are all ways to boost your memory in general. Today we're going to learn strategies that boost your memory in specific instances. To do this, we're going to have to review a couple different forms of memory, and we're going to talk about how the brain stores them. We learned about 4 kinds of memory on Monday. One of them was episodic, one of them was semantic, one was procedural, and one was priming. Those are the 4 different kinds. Does anyone remember what semantic memory does? Charles, your hand jumped straight up in the air, but I'm going to give people a little bit of time. Does anyone remember what semantic memory does? Does anyone remember what semantic memory does? John, say?
Okay, like I'm going to level. Like semantic, to me sounds like cement, I guess. So no, this has a good reason. So semantic memory means like say you think something, like you like don't lose that thought for like a really long time. Is that what it is?
Ooh, okay, that would be more like a long-term memory.
Oh.
But this is a different kind of memory. Let's go back to Charles.
Short-term memory?
It's often in short-term memory, but it's actually a special kind of long-term memory, but you can use it in short-term memory and access it in short-term memory. It refers to what you're remembering, though. Semantic memory remembers a certain kind of thing. Last guess. No, last guess.
It remembers color.
Color is one example of something that could be semantically remembered, but not the sight of color, just the name of color. Can somebody think of another example of what semantic memory could be? Try.
Like shapes.
Could be the names of shapes, like identifying a quadrilateral or something. I'm giving. See if you can get to the higher category. I'm giving you examples. It could be mathematical, like methods or terms or formulas. Facts, exactly. What is it?
Facts.
What is it?
Facts.
So semantic memory is any kind of fact. It's the hardest memory for us to have. We take that and contrast it with episodic memory. What is episodic memory? It's much easier for us to remember, and the name is a hint of what it means. Try.
Like you saw, or is it like once you learn that you like keep it in your brain as a memory?
But how do you keep it in your brain? Because you can learn semantic memory, you can learn facts. But episodic memory is stored differently. How is it stored? How is it stored? Go.
Isn't it because it's the like when you do it in repetition, like you do it over and over again, like you said.
That could be semantic or episodic. Think of an episode in a TV show. What is episodic memory? What is episodic memory? Last one. Stories. What is it, class?
Story.
We're going to talk about these two kinds of memories in a moment, but first let me explain the rules of the game. Turn the page. Right now, your pencils need to be down because otherwise I'll think you're cheating. We're going to play 6 rounds of concentration. The first round you're going to play cold. And then every round after that I'm going to teach you a new strategy for storing memories differently. So the first round that we're going to do will have exactly 12 words you need to remember. I know there's 15 blanks, they're extras in case you mess up. The 12 rounds that... I'm good. If you're good, I'm good. The 12 words you need to remember, you're going to write in the blanks. Now, you're not going to write them until I say write. You'll have 30 seconds to look at the list on the board. During those 30 seconds, you shouldn't write anything. If you do, you're disqualified. After the 30 seconds is done, I'll say write, and you'll have 60